Well, thank you for the introduction, and thank you everybody for taking the time today to come watch these presentations, and for the CIC for organizing it. Today we're going to talk about something about open source code and how it's entering our industry. So it's assumed that you're part of the AECO paradigm and that you're interested in what's coming next after BIM. And we're going to talk a lot today about a lot of different things, but a lot of it's going to be revolving around data. We're going to talk about data in a way that you probably haven't heard data talked about, and hopefully that it gives you some ideas of what you can do in your job differently and innovatively. The main thing today is to walk out of here. I hope everybody can walk out and think of buildings and city as data. Data points, generation of data points, collection of data points. We want to think of things as data, especially if you're a designer. Most of our work is about generation of data, whether that's drawings or whatever that is, it's data. And that's why I always want to talk first about the very brief history of what we have used in our industry, because we have a rich history of different forms of data. But first, just let me introduce myself. My name is Emidio PIERMARINI, and I'm an associate director here at Buro Happold. I run our computational consulting division, which is a new division that leverages first principles design and experience from complex projects and computer science to solve the industry's biggest problems. And we'll show you some of that by the end of this presentation today. The key here is it's all related to new forms of using data. And again, like I was saying before, our industry is one that has grown up with different forms of data. If you go back to the age of the master builder, they were using three-dimensional models, whether it was Brunelleschi and little carved turnips, whether it was Gaudi and hanging chain models. That was the encapsulation of the data that represented the design and the building. Even when we had physical drawings, again, these are physical models. They're two-dimensional models now, but again, Alberti came up with the idea of drawings. We still use these today. Centuries later, we still use physical drawings. But again, there's a separation. Even with the language, we say that they're drawings. We start to forget that they're really data about the building. And that's why this quote from Sutherland is one of my favorites, because it gets down to brass tacks very quickly. Sutherland saying, what is the data when we talk about drawings? Dirty marks on paper. Now, I don't know if this was meant to be disparaging, elitist or whatever, but I love it from the perspective of it gets straight to the point. Don't forget what you're talking about here. You're talking about data, and the data is the medium is dirty marks on paper. And again, I like this idea of being frank about what are we talking about. Let's go back to first principles, because even CAD, you could say the same thing. When we print that out, it's dirty marks on paper. When it's in the computer, it's still just digital dirty marks on paper. There's no real data structure behind a set of CAD drawings. There's a bit, but again, it's not something like when we talk about BIM. And we're going to talk about BIM here today because Ada had led in with, Hong Kong's going through our BIM revolution right now, and it's an interesting journey to be a part of. But if you're like me, around 2012, I was sitting down and said, what's this thing called BIM? I remember very specifically, the person who was giving the tutorial said, right now, when we're in the dirty marks on paper era, what you see on the drawings is different highlighting here, geometry of the thing, dirty marks that describe the geometry of the thing, dirty marks that describe the properties of the thing's geometry, and dirty marks that describe the properties of the thing. Thing, 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 thing. This is where the structure of BIM, this is the revolution that BIM gives us, is that actually what we're going to do is the hierarchy of information in BIM, shown here on the right, is that we're going to have a thing and everything else packed inside of it. It's this hierarchy of information. And we actually are moving closer towards representing this thing in the computer as we will in reality. We will represent this thing in the computer as we will in reality. And that is the fundamental thing that when I first started getting involved in data in the AEC industry, that was what I was said, oh, that makes sense, right? But we forget that. We often do forget that along our BIM journey, that is the fundamental shift. We don't talk about it as data, and we sometimes don't talk about it even in terms of this radical shift in the way that we change our structure of our data. And there's a few reasons why, and none of them are bad. They're all true. First of all, BIM has manifested itself as a proprietary product. If you talk to anybody, they say, what is BIM? BIM is Revit. A lot of times comes up, some other softwares, but most people would not go straight to it's a hierarchy of information that is different from before and dirty. No, they talk about software. Again, very useful softwares, but let's be honest here. That's a distraction. People start to get confused. What is BIM? They don't see it as data. They see it as software. The other thing is throughout all these eras that we just went through, since Alberti, the output has consistently been paper drawings, especially here in Hong Kong. So just because we're changing to BIM doesn't mean anything has changed. And again, this is seen to be, well, we'll use BIM to make paper drawings a lot more efficiently. That's true. There's definitely efficiency gains to be made. But again, it's a distraction from the idea of seeing BIM as the information modeling part of it. It's the idea we start focusing more on software now, more on the outputs and not what has changed. And one of the final things that has slipped under the radar here as we go into this era is we have this amazing software that now allows us, I don't even know how it was done before when it was the CAD era. I didn't grow up in the CAD era. You have this model and everybody from around the world, COVID-19 doesn't stand a chance against BIM. Everybody from around the world could be chucking in information into this model. True co-collaboration when you compare it to previous eras. Pretty cool, right? But again, this is something that also lopped on top of us at the exact same time as the radical change in the data hierarchy starts to distract from the idea of data. Let me give you an example of this. You got to love BIM. You can see right away, you can do a little audit in this computer and say how many objects are there. And you say to me, Emidio, look, the computer knows it hosts 4,533 of those objects that you talked about. Each one of those objects in that list has that hierarchy that you were talking about. They're not dirty marks on paper, they are objects. They are representing the thing in the computer as it will be in reality. So what's the problem? Again, if we look even on a drawing, that exact same structure exists, that exact same thing. So when you look at this, and this is the kind of thing that as someone with an engineering background does, they combine everything we just talked about into one thing. So first of all, we talked about how efficiency in drawing production. So you say, because I have the three-dimensional model, I get this section for free. But actually, when we look at what's on the drawing, what's on the 2D drawing as just data, we ask the computer, what is the data that I'm reading as a drawing? We can see here that there's 38 digital objects that are having to be created in order for me to see that picture and interpret it. And we can quibble over if drawings are the future or not, but again, the data to represent this part of the building needs to be in there. And in this case, it's manifesting itself as 38 data points, and only 3 of those data points are auto-generated for us. In other words, the outline of this beam and slab system, which are pointed out here as floors and structural framing. So even that efficiency gains that we talk about a lot of times with BIM, those of us who have been involved with BIM for many years know that it's not like it's magic. It's not like overnight everything became very easy. It's still a massive amount of work to be able to produce the amount of data that is required to portray a building. Now, this is where this next video comes in place, where I'm actually doing the calculation for a project like this, which is not doing 4D, 5D, 6D, 10D BIM. It's not even that complex of a problem. It's literally just doing the math of how many pieces of information need to be created at least once, and we all know it'll be multiple times, over the course of a very simple project. And you start to see right away that you're in the tens of thousands of pieces of information, that you are, even with a simple project, doing lonely BIM, talking about big data, quote unquote. And again, the way that we see this in the industry is we don't pay attention to the data. We don't see this as an exercise in putting data into a machine. We don't think of that diagram from before where it's a bunch of people. The way that we create 50,000 pieces of data is by people clicking and clacking on a keyboard for the majority of the way we work. We just think of it as, well, we'll just get more people and we'll be able to create more stuff. But that has a limitation. And that limitation is seen on other projects that we're going to go into now that have led to the creation of this thing called the BHOM, which we're going to get into. This is what I'm really excited to share with you guys today. So some of you might have seen me talk before on Morpheus. I was involved in this project for a number of years. It's the reason I came to Hong Kong, and the reason I'm still here in Hong Kong is this brought me here, and I love Hong Kong. And it's because of complex projects like this that I stay here, and it's also because of the reason that we have things like the BOM. Because for projects like this, just throwing more people at a proprietary piece of software to create the data that is required to actually portray something, even just the exoskeleton of this building, is an impossibility. It cannot be done. There is a limitation of BIM, and there's a limitation of how we can actually use it. So in this particular case, we had actually had to resort to a script which actually did the majority of the generation of the data for that exoskeleton of that building. Now, you hear a lot of words in our industry about digital engineering, digital design, computational design, all these different words. And when we hear about the word parametric design, some people would look at what we delivered and say, you delivered parametric design. But this was different, because when you look at what's actually in this script, we are leveraging what's known as object-oriented programming. Object-oriented programming, a principle from computer science that actually encapsulates here the idea of the object itself, not just the object's geometry, which is what parametric design is. So although we're using Grasshopper, which is a flow-based programming language, it's made famous by parametric design, if you look in here, we're actually using text-based code, in this case Visual Basic, to describe with coding the objects that we are designing. We are taking full responsibility for the code behind the engine, which will eventually generate for us the BIM model that will come to be. And again, this is a BIM model. This has embedded within it. It's not just geometry. It has embedded within it a whole bunch of information that is there that is not geometrical. So again, that same hierarchy that we talked about before. The big difference is here is we are doing it ourselves. We are defining these parameters, and we're encoding that using computer programming. And this isn't just someone who is a computer scientist over here and a real engineer or a real architect over here. We're talking about the same person. So myself, with a structural engineering background, I know enough to do all of this stuff, and so do my colleagues. This is the future, not just using the latest gizmo and gadget that came from Autodesk or McNeil Associates. At least that's the way we see it going. So much so that off the back of these complex projects, Morpheus is just one of them, we noticed that this was a trend, that we were consistently taking control down to the level of code, our designs, which is why we created the BHOM, the Buildings and Urban Habitat Object Model. BHOM.xyz is where you can find more information. So what is this? We're going to go a little bit into what is the BOM. Because it's a hard answer, actually. Even though I've presented it before, I've been involved in it. First things first, if you go to this website right now, it's a repository of code that you can gain for free. There are hundreds of thousands of lines of code, some of which, if you're a young person right now, I promise you, those same lines of code, when I joined the industry, made you a superstar. They still will, and now they're out there for free, and they're begging to be used. So it's highly behooving of you to go out there and check this stuff out. So again, open source code just means code that's out there on the internet for free. And the only barrier at that point is that you will go on there and use it. But let's say you're someone who goes, oh, this coding business, it sounds very, very crazy, you know? Well, the code is also exposed in medium that you've already sort of seen before. Maybe not Visual Studio, but I guarantee you, of the 600 people I saw on this call before, you've all used Excel. Some of you have used Grasshopper, and some of you have used Dynamo. So again, this is code that is exposed in familiar medium. Again, you can access the code, but if you don't want to, you can just play with the code. And it's very hard. BHOM. OM stands for object model. Again, we talked before about the thing, the object. This is a library of objects that have been defined online with a set of code that looks like this. So this is the BHOM definition of a point. Not a very complex definition, but this is out there for free. You can use it, you can edit it, you can do whatever you want with it. And the key difference here is he says, well, I got AutoCAD, I got BIM, I got all these different things. Why do I need your definition of a point? Why do I need another point in my life? And the key here is again, it's about that idea of taking the responsibility and understanding that when the projects get too complicated, you need to take that responsibility. So on the left is a tool. It's nothing more than a tool. It will create for you a McNeil and Associates point. On the right is one that will create you a BHOM point. But the key thing there is it's not just a tool. If you don't like the definition of that point, if you don't think that there's something right, if that doesn't fit your workflow, then you can go ahead and just open the code and change it yourself. And you say to me, Emidio, that doesn't make a whole lot of sense. That's a pretty good definition of a point, XYZ. But what about when we start talking about different types of objects, such as a speaker or a crane or a table or a door? Any object. We are one of the few industries that can say we work with objects. We work with things. And therefore, any object we eventually have to wrangle at some point and put it into the computer. This is the epitome of that. This is saying we'll do that ourselves. We're not going to wait for a committee to do it. We're not going to wait for a software company to do it. And at that point, it really becomes interesting because we start solving a few problems and we start moving into this interesting space. First of all, Emily just talked about interoperability. One of the key things, interoperability costs our industry billions of dollars. And the key is when I joined the industry, being able to create one of the links on this graph here was it made you a superstar. Now with the BOM being a central language, a central repository, something that we can all use, it simplifies this graph because now you have a common language, digital language, information from Revit can go to the BOM. And if you have an adapter, what we call these arrows adapters, to somewhere else, it just goes over there. It's this common place where data goes to live. And again, it's not owned by anybody. It's open source. If you don't like it, you can change it to your needs. And eventually, all of us collaborating together, the idea is we will create this democratized language that will actually be the solution to this massive, one of the many massive problems that we have in our industry, which is called interoperability. Again, if you're a manager watching this, there's huge gains to be made on, you're paying for billions of those dollars of interoperability problems. So on a recent project here in Buro Happold, we actually generated not just the roof of a stadium, not just the bowl, the entire structural model of the stadium via the BOM, and then it was a click button exercise to put it over into finite element and into Revit. Again, not touching BIM, quote unquote, the commercial BIM that we always talk about. We have taken care of that upstream, and the computer will take care of the heavy lifting. Again, some of you might have heard of things like Speckled or 3D Repo, which are also open source projects. Again, this is the thing about code being open source. There it is. These guys have already made connections to the BOM because, again, it's one of those things. Now the data can flow from one medium to another, one discipline to another, no problems. And this is where it really gets interesting because now we're not talking about data as this thing that's in a software. We're talking about data as data. We're talking about it as code, ones and zeros. And that opens up a whole range of possibilities for us as designers to start linking together all of these different disciplines and creating very interesting data sets during design and after design. We're literally working with big data as people in Silicon Valley do. We're no longer bogged down by all of the latency and other things that come with proprietary software. We see things as data. So in this case, we're using things called transdisciplinary modeling, where we're actually linking together all of the modeling that goes into different disciplines via one medium, which is the BOM. In this next video here, you can see we're doing that. In the first video, we're showing in the GIF, we're showing it for a tall building. But in this video here, we're showing you again how we can do this for something like an airport. And again, the idea here is very much we are going to just use data for data's sake. We are going to be able to, because we own the data now, we can create more deep insights than ever before. So we're not just sitting here and drawing the building with dirty marks on paper. We're not just CADing it up or putting it into BIM. We are actually owning the paradigm of the data, and we are letting ourselves walk into this new era where everything is driven via analytics and big data. So what is the conclusion? What is the point of all this? I get excited about this, but I think it's really important. If you're a young person on this call, if you're just joining the industry, the best advice I can give you right now is learn to code. I won't tell you a language. I won't tell you what language to learn because they're all the same. It really is. And it's really important that you learn this because it will be a major part of your career. Stephen Hawking said so, and it's still true today. And if you're anybody else who's interested in what comes beyond what we see as BIM, the standard BIM that we all think of right now, if you're ready to take another step into the future, this is the perfect time to start getting involved because the bomb is out there. It's ready to have anybody join it. It's available to anybody in the world. And again, this is the future that we all should be looking towards to liberate ourselves from the crutches that we have taken on in the past decades. So I want to thank everybody for their attention and for the CIC for inviting me, and to all the other speakers for being such good teammates. Thank you.